Hi there. Today I want to talk to you about calculating infusions, specifically infusions that use giving sets. Now there's a key formula that we use in all cases of infusions, whether it's via a pump, syringe driver or indeed a giving set. And that formula is rate equals volume over time. So volume over time is our key to getting into calculations of infusions. However, we've got to watch out for units. The units we require for a calculation of a giving set infusion are drops per minute, sometimes abbreviated to DPM. Now supposing during the setup of the question we found ourselves with milliliters per minute, then we'd have to modify this and multiply it by what is known as a drip factor, and that is something you're usually given in the question. If on the other hand, after setting up the question we had milliliters per hour, possibly the more common one, then we not only have to multiply by a drip factor to take care of the milliliters converting to drops, but also we have to have 60 as well to take care of the hours converting into minutes. In other words, we're going to multiply by drip factor over 60. So I'm going to carry out 4 examples of giving set infusion questions. And as it states here, the units we need to express the answers in are drops per minute, and we need to ensure that all our answers are expressed as a whole number. It's very likely that we will find ourselves in a position where we have to round to the nearest whole number. So let's dive in. So in our first question we are told that we need to give an intravenous drip of 1.1 litre of normal saline over 5 hours. And we're told the drop factor, or as I call it, the drip factor of the giving set is 20. I don't need to worry about those units of drops per mil. Now right away I've noticed that they've given us the volume in litres, and I always want the starting volume in milliliters. So my first step before even starting on this question is to convert 1.1 litres to milliliters. Now I know that means I need to times it by 1000, so by hand I would simply move the decimal point 3 places to the right, and you can see here that there is space for 2 extra zeros. In other words, 1.1 litres is going to be 1100 milliliters. Let's just check that with a calculator that I've not made a mistake. 1.1 times 1000 does indeed equal 1100. Okay, we're now ready to set up the question properly. Our starting point is always the formula, volume over time. We now have our volume, which is 1100 milliliters over, and the time they've given us is 5 hours. As we want not mils per hours but drops per minute, we're going to have to multiply by the drip factor over 60. Now they told us the drip factor is 20, and I'll put the 60 there. So that drip factor is ensuring our units aren't in mils but drops, and that value of 60 is ensuring that our time is in minutes, not hours. Okay, we're now ready to do some simplification. Well, if I look to simplify that first fraction, I can see that 5 goes into both top and bottom. So 5 into 1100, 5 into 1 doesn't go, 5 into 11 is 2, remainder 1, 5 into the other 10 is 2, and 5 into 0 is 0. So our simplified fraction becomes 220 over 1, because 5 went into 5 one times, and I can see that with that 20 over 60, well, I can cancel those zeros, that's the same as dividing by 10, and then I can just halve top and bottom, so it becomes 1 over 3. Now this calculation becomes easy. To multiply two fractions, it's always top times top, bottom times bottom, so that just becomes 220 over 3. And then to work out our final answer, I'll make some space up here. 220 over 3, 3 into 220, 3 into 2 doesn't go, 3 into 22, well that's 7 times, which takes me to 21, so I have 1 left over. 3 into 10 is 3 remainder 1. I've got remainder with nothing at the end, so I'll have to go decimal just to see what happens. Put a dot and a naught, and then say 3 into 10 again is 3 remainder 1. That's going to go on forever. The answer will be 73.3 recurring. Now we need to round this to the nearest whole number, so our final answer is just 73 drops per minute, which I'll write as DPM. I'll use the abbreviation, and you'll notice that we rounded what some people call rounding down, but because that value there was under 5, so 73.3 to the nearest whole number is just 73. Let's check all that with a calculator. And the nice thing about using the calculator is we don't have to do all of these steps. Once we have set up the 1100 over 5 times 20 over 60, we can put that directly into the calculator. So, clear the memory, 1100 divided by 5 times 20 divided by 60 does indeed equal 73.3 recurring, so that confirms our calculation. Excellent. On to the next question. The next question tells us to administer 500 milliliters of solution over 3 hours, and the drop factor of the giving set is now given as 15. So now there's no need to convert. In this case we already have our volume in milliliters, so we can proceed directly to the formula. As before, start with the formula, volume over time, and that is 500 milliliters over 3 hours. And just like last question, because we have both milliliters and hours in the setup, we have to multiply by the drip factor, which in this case is 15 over 60. And that converts both milliliters and hours into drops and minutes. Okay, again I'm going to look to simplify. Now I can't simplify that first fraction 500 over 3 because 3 doesn't go into 500, so I'll leave that as it is. But 15 over 60, well, 5 goes into top and bottom, 5 goes into 15 3 times, and if you work it out, 5 into 60 is 12 times. And then we might realise we can simplify again because 3 goes into top and bottom, so that comes right down to 1 over 4. So our question, 500 over 3 times 15 over 60, has been simplified to 500 over 3 times 1 over 4. Well, that's okay. 500 times 1 is 500 and 3 times 4 is 12. Now 500 over 12 does simplify. I can halve that to become 250 over 6 and halve it again to become 125 over 3. Our final calculation needs to do a division. 3 into 125. We can see it's not going to go in directly because those digits 1, 2 and 5 do not add up to 3, 6, 9 etc. 3 into 1 doesn't go, 3 into 12 is exactly 4, 3 into 5 is 1 remainder 2. I have remainder by itself, so I go decimal, top and bottom, and add a 0 on. 3 into 20, that goes 6 remainder 2, and we can see that our answer that is emerging is going to be 41.6 recurring. So again, when we round that to the nearest whole number, it's going to be 42 drops per minute. And again, I've used DPM as an abbreviation. So like the last question, let's test that with the calculator. Clear the memory. I have 500 over 3 times 15 over 60. And our answer is indeed 41.6 recurring, and we would be expected to know how to round to the nearest whole number, giving us 42. Just to reiterate, the rounding occurred because that value there after the decimal was 5 and above, and that allowed us to round to 42. Excellent. On to the third example. We're now told to administer 800 milliliters over 3 hours. Again, our volume is already milliliters, so we can proceed directly to our formula, volume over time, and our volume is 800 milliliters. Notice my habit of putting the units in as I unpack using the formula. Over 3 hours, 3 hours. Putting the units in allows me to think about my units. What am I going to multiply by to convert that to the appropriate drops per minute? Just as before, I have mils per hour, and as I want mils per minute, I must multiply by the drip factor over 60. We are told here the drip factor is 20, and there's a 60 on the bottom. I don't want you to get used to the idea of putting in 60 always, because this unit here is sometimes in minutes, and then we wouldn't have the 60. Okay, let's look to simplify. Now 800 over 3 does not simplify, so I'm just going to write that out again over here. But that 20 over 60 does, again. Cancel the zeros and halve it. So it becomes 1 over 3. This is a straightforward one to do. 800 times 1 is 800. 3 times 3 is 9. That does not simplify any further, so I go straight into my division. 9 into 800. Well, 9 into 8 doesn't go, and 9 into 8 is 8 times, because 8 9s are 72. So 72 is 8 to 8 from 80, so I happen to have a remainder 8. I think we can already see where this is going. 9 into 80 is still 8 remainder 8, and have remainder by itself, so I must go decimal, top and bottom, and add a 0. And 9 into 8 is still 8, remainder 8, and you can see our answer is going to be 88.8 recurring. In other words, when we round, it's going to be 89 drops per minute. And again, our rounding has occurred because this digit is clearly 5 or above. Okay, check with the calculator. You can see the hard work is just setting up the calculation. Once you have that set up, then the calculator will take care of it. So 800 over 3 times 20 over 60 equals 88.8 recurring. That 6 at the end is simply what's called a rounding error on behalf of the calculator, but we don't need to worry about it. Clearly that answer rounds to 89. Okay, final question. You are requested to administer 150 milliliters of solution over 20 minutes. The drop factor of the giving set is 15 drops per minute. My volume units are in milliliters, so I'm quite happy with that. Start out with the formula, volume over time. Use that formula to unpack the question, so my volume is 150 mils. My time is 20 minutes. And finally, we have an occasion where we do have to take extra care with our units. We now have mils over minutes, or mils per minute, so we only multiply by the drip factor. There is no 60 on the bottom because we already have minutes expressed correctly. Now, many people, when they're doing this mathematically, like to have a fraction times a fraction. So I'm going to write that 15 over 1 just so it looks like a fraction times a fraction, but you don't have to do that. There's clearly no way I'm going to be able to simplify that 15 over 1, but I can simplify 150 over 20 just by crossing off those zeros. So not much simplification went on there, but it became 15 over 2 times 15 over 1. Most of us would not know what 15 times 15 is, so let's just work it out on the side here. 15 times 15. I'll use the column method. Some of you might use the grid method. 5 times 5 is 25. 5 down, carry 2. 1 times 5 is 5 plus a 2 is 7. And as I finish with that first carry, I'm just going to get rid of it. On to the next line, because I'm timesing by a digit now in the tens column, I must put a naught first. 5 times 1 is 5. 1 times 1 is 1. I now add those two up. 5 plus 0. 7 plus 5 is 12. 2 down, carry 1. 1 plus the 1 I've carried is 2. So 15 over 2 times 15 over 1 equals 225 over 2. I need a bit more space for my calculation. So over here I'll just do my last bit. 225 over 2. So 2 into 225. 2 into 2 is 1. 2 into the other 2 is also 1. 2 into 5, well that's 2 remainder 1. We'll have remainder by itself, so decimal points and add a 0. And 2 into 10 is 5. Our final answer is 112.5, and to the nearest whole number, that is equal to 113 drops per minute. And for one last time, let's check with the calculator. Clear the memory. 150 divide by 20 times by 15 divide by 1 equals 112.5, and we have correctly rounded to the nearest whole number. Well, they were 4 questions that on the face of it look quite challenging, and although I've created quite busy slides in solving them by hand, you can see that the setting up of the question is very straightforward. It always starts with volume over time. You always make sure the volume is in milliliters. You know there's going to be a drip factor involved, and there will be a 60 on the bottom if your time is in hours, and there will not be a 60 on the bottom if your time is in minutes. Thanks for watching.